Hello, my name is Khyati and I will be presenting my URECA poster. Imagine being able to take a photograph of an electron moving, not a blurred image, a crisp snapshot of something happening in 1/4 of a second. That is exactly what ultrashort laser pulses make possible, and understanding how they are created is what this project is all about. Most people think of lasers as continuous beams, like in a sci-fi movie, but lasers are actually changing the world. Science and medicine produce pulses that are so brief, they make a camera flash look like an eternity. How do you create something so short? The answer lies inside the laser itself. A laser cavity is essentially two mirrors which are facing each other, trapping light and allowing only specific frequencies to bounce back and forth. These are called longitudinal modes. Think of it like a guitar string with only certain notes resonate. Now imagine forcing all of these notes to play exactly at the same moment. Instead of a continuous hum, you're going to get a single sharp strike. That is mode locking, and that sharp strike you hear is your ultra short pulse. To explore this, I built a Python simulation from first principle. The flowchart that you see on the right top shows exactly how the code works, step by step, from defining cavity parameters, assigning phases, computing all the pulse envelopes, and all the way to generating the intensity plots that you see at the bottom. When I ran the simulation for 5, 11, and 21 locked modes, the results were striking. The pulse gets dramatically narrower and the peak intensity jumps all the way from 25 to 441. More modes locked mean a shorter, more powerful pulse. The physics and the code, they agree perfectly. The implication of this goes far beyond the lab. Mode locking lasers are used in eye surgery, in fiber optic communications, etc. Now, the natural next step is to model what happens once these pulses leave the cavity and travel through the optical media where they stretch, distort, and interact with the material. This is governed by the nonlinear Schrodinger equation, and implementing a numerical solver for it is exactly where the project is headed next. Thank you.